Hello, my name is Thomas, and today in this video we're going to be talking about the difference between vector and raster graphics and the advantages and disadvantages of each type of graphic system. Now, each of these systems has its own uses, and both of them work in very different ways, and so we're going to go over the difference between the two. So to start with raster graphics works on a pixel by pixel basis. Basically what that means is that there are hundreds to thousands to even millions of pixels in an image. Your screen is made up of pixels. That's what your resolution is. Generally, a common screen resolution is 1920 by 1080 for standard HD, but 1440 by 1080 is also a common screen size, ultra wide HD. Both of those are pretty common, but what that means is that if you split up your screen, every pixel, into rows and columns, it means that for 1920 by 1080, it means that there's 1,920 columns on your screen, and there is 1,080 rows top to bottom. In raster images, the resolution works the same. It's just now we're working with images instead of screen resolutions. The number of pixels on a screen, it's now the number of pixels in an image. So in this image is about 3,000 pixels by about 4,500 pixels. And so what that means is that there is, in total, about 12 million pixels in this one image. And if we zoom in, really far, you can see that each of these pixels has its own distinct color. Some are very similar, like this pixel and this pixel, or this pixel and this pixel. I think these two are actually the same. But each pixel has its own unique color profile. And what all these colors and all these pixels do is, if you put them next to each other, you'll get this very clean image. Now, the big problem with raster graphics is, like I pointed out when I was zooming in, we lose some of that image quality. You know, from this close, you can see that the texture on the walls, on the bricks of this temple, they're not as crisp, they're not as clear as they were from way out here. From out here, this looks like a very well detailed image, but as we get closer and closer, especially down here, you'll see that that's just not the case. And when you're scaling things up, that becomes a big issue, because if you scale something up large enough, you'll eventually start to see the pixels, and that's just not good. The way around this is by using higher resolution images. Higher resolution images can be scaled further before you start to see the pixelation. Now, the big advantage of raster images is that when they are within the same size, because every pixel has its own color value, that makes modification of these images very easy. Applications such as Photoshop, funny enough, were designed with the idea of modifying raster images, and that's the reason that I can, grab one of these tools. We'll grab like one of the clone stamp tools. If I bump the size up, I can sample down here and paint that up here. And you can see that, it modifies just fine. This up here looks just as crisp as down here. But of course, as we get closer and closer, we'll start to see that that's just not the case. It's not actually crisp indefinitely, it's just crisp from afar. But there's a lot of detail when it comes to the shading. And when we get to vector graphics, you'll see that that's one of the issues. Speaking of vector images, I decided to hop into Adobe Illustrator to talk about them. What vector images are a mathematical calculation of a shape. Now, what this means is that there's not a pixel-based system like there is with raster-based images. And so the biggest advantage of this is that images can be zoomed in indefinitely without losing any resolution. So, for example, this image right here by Dedues. This image was made in Blender using the grease pencil, which is Blender's version of a vector graphic system. What that means is that rather than calculating every pixel on the screen, what it'll do is calculate that line and calculate the slope of that line and the contours of that line or shape, and it'll use that calculation and scale that whenever you zoom in or zoom out or modify the shape. The huge benefit of this is that these can be printed at any size. So quite literally, you could have something printed on a 1-inch diameter button and have that same image blown up all the way to the size of a billboard or a building or on an aircraft. And you can see this a lot. Logos for companies are often done in vector graphics because of this flexibility when it comes to printing size. Coca-Cola, that can be put on a bottle, a few inches wide by like half an inch tall, an inch tall, and then they can put that on a blimp or on a vehicle or on a billboard, anywhere that they want, because it's a vector image. It's hugely beneficial when it comes to things like logo design, graphic design. You'll often see this in sign making, vinyl making, t-shirt printing. This size capabilities allows huge flexibility without any loss of resolution. Now this sounds all great, and it sounds like vector images are the image format of the future. But the big problem with this is that even though these can be scaled up to any resolution, they do have to be quote-unquote relatively simple. And that doesn't mean like your image has to be simple. It just means that the common use of vector images is for relatively simple graphic design, and that's because you can't have the same modification properties that Photoshop does because of the way the shapes are created, because of the calculations and how this format works. The big limitation is that you don't have the modification properties like Photoshop. I can't take an image of, for example, that temple. I can have it quote unquote vectorized, but unless I have that 12 million little boxes, unless I have 12 million boxes that are, assigned to each pixel, I won't get the same image quality that I got from the actual raster image. And that's the big problem. Like, even though this image is in Photoshop, this is technically a raster image because it's still pixel based. Now, in the actual file format, if I were to get this as, say, an SVG file, which is the essentially standard vector graphics format, I could, if I had the SVG file, I could scale this up to the size of a billboard and not lose any resolution quality. But as just an image, I am limited on the pixels. See right here, you can see all the pixels. To demonstrate this infinite zoom quality that vector images have, I'm just going to quickly draw an ellipse. I'm actually going to draw it on a new layer and hide this one. But if I were to, let me change the color. If I were to just draw a circle, and we'll actually go back to Photoshop so I can show you the difference. But if I start zooming in on the circle, so from out here, it looks like a perfectly round and perfectly smooth circle. And as we zoom in, you can see that this line still looks perfectly smooth. It's perfectly flat from this point to this point. Now it's limited by your screen resolution, the resolution of your actual physical screen, but as we get closer and closer, this is the closest we can go. Although theoretically you can go even further. This line is still perfectly linear, or rather perfectly elliptical. Now, if I hop back into Photoshop, back to our monument, if I hide this and draw a circle, and we'll actually do this with no anti-aliasing, and fill it. You can see that from out here it looks all fine and dandy and smooth, but as we zoom in more and more, start to see the pixels, and then you can see the big problem with raster images is that you get this blocky edge. It's not a perfectly smooth edge. From a distance, it gives the illusion of being circular, but if I were to say, blow this up to the size of a billboard, I couldn't get anywhere near that here, but if I were to do that, zoomed in, we can already start to see some of that blocking just from out here. Get in just even slightly further and we can see it even more. If we keep zooming in, we can actually start to see it. It started to, in order to accommodate this size, it smoothed out some of the edges, so it actually looks somewhat smoother than it did before. But we still can see that, you know, if you follow my cursor, that's where the original edge was. That's that blocky edge. And so this is the big drawback of raster images versus vector. You can see it's beautifully buttery smooth. But that'll be it for this video. I hope you enjoyed it, and I'll see you in the next one.